Good morning, students. Today we are going to start our new lesson, that is chapter 13, limits and derivatives. So the limits and derivatives, all the formulas and the basic concepts I have sent through the broadcast channel. Please go through it, all the formulas and the concepts. I am going to start the exercise 13.1. The very first question. Short form of limit can be written as LIM. Limit x tends to 3, the function is x plus 3. This function x plus 3 is already in the standard form. Standard form means it is already in its simplest form. If the limit is not in the standard form, we have to first convert it in the standard form, that is the simplest form, and then only we have to substitute the value of the limit, that is x equals to 3. So it is already the function x plus 3 is in simplest form. So x, in place of x we substitute 3. 3 plus 3 is equal to 6. That is our first question. Limit x tends to 4. 4x plus 3 upon x minus 2. This function is also, it is in the simplest form. So directly we can substitute in place of x as 4. 4 into 4 plus 3 upon 4 minus 2, which is equals to 19 by 2. The next question, limit x tends to minus 1, x to the power 10 plus x to the power 5 plus 1 upon x minus 1. It is also the function which is the simplest form. So minus 1 to the power 10 plus minus 1 to the power 5 plus 1 upon minus 1 minus 1. So after simplification we get minus 1 by 2, the value of the limit. Now comes the seventh question. Limit x tends to 2. In this question, this function, it is not in the standard form. If I am going to substitute this x equals to 2 directly here in this function, what we will get? Let us see. 3 into 2 square minus 2 minus 10 upon 2 square minus 4. 3 into 2 square 12 minus 2 minus 10 upon 4 minus 4, which we get as 0 by 0 form. So 0 by 0, it will convert the function to an infinite function. So this should not be happen. Whenever we are substituting directly, we should not get anywhere else when we are solving the limit questions 0 by 0 format हमें कहीं पे भी किसी भी लिमिट के सॉल्यूशन में नहीं मिलना चाहिए. It means that if we are getting a 0 by 0 format, it means that our function is not in the simplest form. We have to first convert it into the simplest form, cancel the simplest, cancel the common factor, cancel it the common factor by factorization method, and then you, after getting the simplest form of the function, you substitute the value. So here it's so quadratic equation splitting middle term. I have factorized it. 3x square minus 6x plus 5x minus 10, and denominator a square minus b square. So x minus 2 into 3x plus 5 factorized the quadratic polynomial of the numerator one, and the denominator x minus 2x plus 2. So it is x minus 2, the common factor is here cancelled out. Now the standard form or the simplest form of this function becomes limit x tends to 2, 3x plus 5 upon x plus 2. Now we can substitute the value x2. So 3 into 2 plus 5 upon 2 plus 2, 6 plus 5 upon 4, 11 by 4. Now the next question, it is a very important question. Limit z tends to 1, 1 upon z cube minus 1 upon z to the power 6 minus 1. So 1 upon z cube can be written as 1 upon z to the power 6 to the whole square minus 1 square, to make the format of a square minus b square. If directly we are going to substitute z equals to 1, 1 by 1 minus 1, 1 by 1 minus 1, we will get a 0 by 0 format. It means that it is not in the standard form. So a square minus b square, a minus b, a plus b, the common factor is cancelled out, and after getting the simplest form of this function, we substituted the value z equals to 1, and we get our final answer as 2. Now let's come to the question number 8. Limit x tends to 3, x to the power 4 minus 81 upon 2x square minus 5x minus 3. If we are now going here to substitute directly as x3, 3 to the power 4, 81 minus 81 will become 0. And here also when we substitute in the denominator x equals to 3, we will get a 0 by 0 format. When we are getting 0 by 0 format means it is not in a standard form. So this x to the power 4 minus 81 can be written as x square the whole square minus 9 square, which becomes in the form of a square minus b square. So a minus b, a plus b, and the denominator quadratic polynomial will be factorized by splitting the middle term. So 2x square minus 6x plus x minus 3. Again this x square minus 9 can be written as a square minus b square format, x square minus 3 square, x minus 3x plus 3, x square plus 9 upon x minus 3, 2x plus 1. So this x minus 3 common factor will be cancelled out, and the remaining part is our simplest form of this function. So now directly we can substitute the value x equals to 3, 3 plus 3, 3 square 9, 9 plus 9 upon 2 into 3 plus 1. At last we are, after simplification we are getting 108 upon 7. Now the question number 12, limit x tends to 2, 1 upon x plus 1 upon 2 upon x plus 2. Clearly we can see that if we are going to take a LCM 2x, we are getting in the numerator 2 plus x, and x plus 2, the common factor will be cancelled out. So we are left out with limit x tends to 2, 1 upon 2x. So 1 upon 2 into 2, 1 by 4. Now the 13th question, limit x tends to 0 sin ax upon bx. Limit x tends to 0 sin ax. Here we are going to multiply the numerator and denominator with ax. So ax, as here the theta angle is our ax. We can't take out a out of the angle. So ax, this is complete theta, and this is, there must also be a ax. As we know that the formula limit theta tends to 0 sin theta upon theta can be taken as 1. So here it must be limit x tends to 0 sin ax upon ax. So into ax upon bx. So this x and x will be cancelled out. A by b is taken out. Limit x tends to 0 sin ax by ax. By this formula, this value will become equals to 1. So a by b into 1 equals to a by b. The 19th, limit x tends to 0 x sec x. So directly we can substitute the value 0 into sec 0. Sec 0 is 1. So 0 into 1 equals to 0. 21st question, limit x tends to 0 cosec x minus cot x. So limit x tends to 0 cosec x can be written as 1 by sin x, and cot x cos x by sin x. When we take the LCM, limit x tends to 0 sin x, 1 minus cos x, and 1 minus cos theta is 2 sin square theta by 2. So 1 minus cos x is limit x tends to 2 sin square x by 2 upon, and sin theta is given by 2 sin theta by 2 cos theta by 2. So sin x, 2 sin x by 2 cos x by 2. So sin x by 2 cancel out, 2 and 2 also cancel out. So remaining sin x by 2 upon cos x by 2 will be tan x by 2, as sin theta divided by cos theta is tan theta. So limit x tends to 0 tan x by 2. After substituting the value of x 0, it becomes tan 0, and tan 0 will be equals to 0. Now here comes the question number 15. Limit x tends to pi sin pi minus x upon pi into pi minus x. This 1 upon pi can be taken as out of the limit 1 upon pi. Limit x tends to pi sin pi minus x upon pi minus x. Let us take pi minus x to some other variable t. When x tends to pi, when x की लिमिट पाई है, तो अगर यहाँ x के जगह में पाई पुट अप करेंगे तो पाई माइनस पाई t की वैल्यू क्या हो जाएगी 0. So therefore when x tends to pi, t tends to 0. So 1 upon pi limit t tends to 0 sin t upon t, as we know that limit theta tends to 0 sin theta by theta is equals to 1. So limit t tends to 0 sin t by t will be equals to 1. So 1 upon pi into 1 will be equals to 1 upon pi. Now the question number 20, limit x tends to 0 sin ax plus bx upon ax plus sin bx. So we just multiply the numerator with ax and divide it with ax, and denominator we multiply with bx and divide it with bx, the denominator part. Now this a by x and x can be cancelled out, a by b can be taken out of the limit, limit extends to 0. Just we are separating the limits, limit sin ax plus bx upon ax divided by limit extends to 0, ax plus sin bx upon bx, this denominator part. Now we will separate it, limit extends to 0 sin ax upon ax plus limit extends to 0 bx upon ax, limit extends to 0 ax upon bx plus limit extends to 0 sin bx upon bx. As we know that limit theta tends to 0, sin theta by theta is 1. So this part will become 1 and this part also will become 1. And this x and x will be cancelled out, we will get b by a, so it becomes 1 plus b by a, and x and x here cancel out, a by b plus 1. After simplification we will get the result is equals to 1. Now the 27th question, limit x tends to pi by 2 tan 2x upon x minus pi by 2. Let us take x minus pi by 2 equals to t. When x minus pi by 2 is equals to t, x will become transposite pi by 2 plus t. So when x tends to pi by 2, here the limit x is given pi by 2. So in place of x, if I am going to substitute pi by 2 minus pi by 2 0, t will tends to 0. So limit t tends to 0, tan 2 in place of x substitute pi by 2 plus t upon this complete t. Limit t tends to 0, multiply this 2 inside this, 2 into pi by 2 pi and 2 into t 2t, so pi plus 2t. And tan 180 plus theta is tan theta, so tan 2t, and we multiply and divide with 2 so that we get in the form of limit theta tends to 0, tan theta by theta equals to 1. So limit t tends to 0, tan 2t upon 2t will become 1, so 2 into 1 equals to 2 is our answer. Now let's go to the example 3, page number 297. Limit x tends to 1, x to the power 15 minus 1 upon x to the power 10 minus 1. If directly we are going to substitute x equals to 1, we will be getting 0 by 0 format. So it is based on the special type of limit formula, limit x tends to a, x to the power n minus a to the power n upon x minus a. If we are getting this format, we will get the value directly n a to the power n minus 1. So here it is x to the power 15 minus 1, 1 can be written as 1 to the power 15. So we will get x to the power 15 minus 1 to the power 15. So value of a we are getting here 1 and value of n we are getting as 15. Only thing is that we are not getting the denominator as x minus a, here as x minus 1. So what we will do, we will divide both the numerator and denominator polynomial with x minus 1 to make the format of a limit. So we divide this function with x minus 1 and here also we will divide with x minus 1. So now this becomes in the format of x to the power n minus a to the power n upon x minus a, x to the power n minus a to the power n upon x minus a. So here the value of n is 15 and here the value of n is 10. So we can apply this formula, n that is 15, a that is 1 to the power n minus 1, 15 minus 1, n here n is 10, a is 1 power n minus 1, 10 minus 1. So 15 upon 10, that will become 3 by 2. Now the second, limit x tends to 0 under root 1 plus x minus 1 upon x. Wherever we get in the function the radical format, the radical functions in the numerator or denominator. If we are getting in the numerator, we will rationalize the numerator with its conjugate. If we are getting the radical format in the denominator, we will rationalize the denominator with its conjugate. So limit x tends to 0 under root 1 plus x minus 1 upon x. So here numerator is in the radical form, so its conjugate will be under root 1 plus x plus 1. So we multiply this function with under root 1 plus x plus 1 upon under root 1 plus x plus 1. So it becomes in the form of a minus b, a plus b. So a square minus b square. So square of under root 1 plus x will be 1 plus x and square of 1 will be 1. So 1 plus x minus 1 and plus 1 cancel out. In the next step, x can also be cancelled out. and after getting in the simplest form, we can substitute the value x as 0 and we get the final answer as 1 by 2. Now here I am going to discuss some of the few questions which are very important. Limit x tends to 0 under root 1 plus x minus under root 1 minus x upon x. Here also we will rationalize the numerator as the numerator is in the radical form. So its conjugate will be under root 1 plus x plus under root 1 minus x. So a minus b, a plus b, a square minus b square, 1 plus x minus 1, sign will change, plus x. 1 minus 1 cancel out, x plus x, 2x, and x cancel out. At last we will substitute the value and we will get as the answer as 1. Next, limit x tends to 0, x upon 1 minus under root 1 minus x. Now here the denominator of this function is the radical form. So we will rationalize with its conjugate 1 plus under root 1 minus x, and after simplification we get our answer is equals to 2. Limit theta tends to 0, 1 minus cos theta upon theta square. As we know that in trigonometry 1 minus cos theta is given by 2 sin square theta by 2. Now here it is 2 sin square, sin theta by 2 the whole square. So here we have to multiply with 4 in the denominator. So 4 theta square by 4, 2 by 4 is taken out of the limit. Limit theta tends to 0, sin theta by 2, and this theta square by 4 can be written as theta by 2 the whole square. As we know that limit theta tends to 0, sin theta by theta is given 1. So this value will become 1. So 1 by 2 into 1 square will be equals to its value 1 by 2. Now next, limit x tends to 0, tan x minus sin x upon sin cube x. As we know, tan x is sin x by cos x minus sin x upon sin cube x. Take sin x common from the numerator, it is left out 1 by cos x minus 1. One of the sin x will be cancelled out, in the denominator it will become sin square x. So now taking LCM, limit x tends to 0, 1 minus cos x upon cos x into sin square x. Now we multiply the numerator and denominator of this function with 1 plus cos x, so that it becomes 1 minus cos square x in the numerator, and 1 minus cos square x will become sin square x, and that sin square x will be cancelled with the denominator sin square x. So limit x tends to 0, 1 upon cos x into 1 plus cos x. Substitute the value 1 upon cos 0 bracket 1 plus cos 0, as cos 0 is 1. So 1 upon 1 into 1 plus 1 is equals to 1 by 2 is our answer.